Okay, so you're at the IETF working group, Grow working group at the Ietf108. I'm Chris. That's Yob upside down. He's not in Australia. It's a shocker. Here's the note well and list of resources for the meeting. Blue sheets are, as we just said, taken care of by Medico. We do need a person to take minutes, so if somebody could do that, that would be great. Okay, George is taking minutes. Okay, and the Jabber Scribe, I think, is just going to be the chat in Medico. No real agenda bashing. Oh, boy, my slides are horrible in both of my meetings today. I'll fix these slides up and repost them, but we have some existing drafts. I think these are all still in progress, according to my other view of things. Ideally, we have a presentation about BMP of the Hackathon from Thomas Graff. Is Thomas on already? Getting down the list.
Yes, I'm here. Can you hear me?
Ah, excellent. Yes.
Great.
Okay. Let me find your presentation. And whenever you're ready.
Perfect. Okay. So I'm presenting for the BGP monitoring protocol team from the IETF hackathon. Next slide, please. So our main focus was primarily on correlating the BMP BGP log grip metrics with IPFix, so that we can do flow aggregation. And we have a couple of BMP drafts which we were covering. One was namely the BMP local RIP draft, then the BMP TLV support for route monitoring and peer down messages, as well the enterprise-specific TLVs, the path marking, and the route policy and attribute trace. Besides that, from a functionality perspective, we were also looking at the performance impact, see how BMP is impacting the CPU memory resources of the route processor, and also how it impacts the BGP route propagation throughout the network. Next slide. So from the software perspective, we were using PMACCT at the data collection. On the big data side, we had Kafka as a message broker, as a time series DB, Pivot as a user front end. At the bottom, there is a nice tutorial if you want to set it up on your own. And we were working also on a BMP Dissector update for Wireshark, covering the new BMP TLVs, which I described in the beginning of the slide deck. And for the traffic and the route generation, we were using Spirent. Next slide. So that was the network we created in our lab environment. It's an inter-AS, MPLS inter-AS option C networks with a couple of PE routers, CE routers, and ASDRs and inter-AS route reflectors. So everything was BGP only. On all the routers, we had BMP enabled for adjacency RIP in, out, local RIP, pre-post, basically everything where we were capable of. And I do not see the slide deck anymore. I think it's loading now. Yep, there we go. So can you go to the next slide, please? So from a lab environment, I mean, we started at Ietf108, so we are gradually improving our setup. And from a lab perspective, now this time we added the IPv4, IPv6 traffic generation. We had the CPU memory collection with the young push. And we identified that we have automatized the configuration of the network, but where we need to improve is the test verification. We want to automatize that as well. And the next step is also we want to visualize basically the propagation delay and using basically the BMP collected timestamps. Next slide deck, please. On the PMACCT side, when we used NFACCT and PMBMPD, we were now this time able to correlate the BGP localip with IPFix, even on MPLS PE routers, where prefixes have the route distinguishers included in their update. And we were working also in decoding the TLVs in the route policy attribute trace, and we made some progress there. And by doing that work, we identified a possible improvement in the path marking TLV, since multiple paths can be present in the route monitoring message of the BGP PDUs. In the current implementation, for each path, we need basically a path marking, and it could be theoretically possible then for some paths that we don't have a path marking, and currently the path marking would be unknown, and by introducing indexing, we would be able that we only do the path marking for paths where we have information, thus basically simplifying, reducing the amount of data we're sending to the collector. Next slide. That's just an example of correlating the IPFix information with the BGP localip. So you see here for a given IP source, IP destination, and the route distinguisher from the peer up. You see basically the community attributes from BGP. Next slide. And on the router side, these are the drafts which we are currently implemented. We did some stress tests as described earlier for the CPU memory usage, which I will detail in the next slide. And we were also working on the Wireshark BMP Dissector. Yeah. So this graph here didn't make much sense to us. We need to further investigate. Basically, what it shows is after we enabled BMP, we saw that the CPU increased. We didn't expect it that much without having the updates in the network. And we think it has to do with the way how we measure the CPU usage, and we want to clarify that until the next hackathon, find out what exact CPU resources we need to monitor there to make an accurate description on the CPU consumption. Next slide. I think this one we can skip. This is more detailed, which BPDU, how many routes causing how much CPU impact. So next slide, please. This is about the memory increase before, after BMP is enabled, when 100,000, 500,000 or 1 million routes were introduced, and we see a slight increase. This is actually expected because when you have multiple peers and then basically need to send the the route monitoring messages towards the collector, that there will be some queuing on the router side, and this is will lead into a slight increase in the memory usage. Next slide, please. And here exactly you see that basically the BMP, the increase in memory actually only happens when you have a lot of routes in the network and the propagation suddenly happens. So then the queuing is happening on the router side. Next slide. And we were measuring the propagation delay in the network, but as I said earlier, this is not really accurate. This is just an estimate based on the CPU impact we had on the routers. This will be much more detailed in the next hackathon, which we are doing, where we use then the timestamps from BMP, so we understand basically how quick, with and without BMP on the route reflector in the middle, the propagation will be on the network. So next slide. This is just an example for the route policy trace visualization, the BMP Dissector in Wireshark. Here you see on the right side each TLV, which is described in the draft. Next. And the same thing for the path marking. So we have the pair header, the prefix info TLV, and the marking. Next. The BMP Dissector, the code at Wireshark is currently committed. It should be soon in the next build, within the next couple of days, and can be then downloaded from the Wireshark website. And these are the next drafts which we'll be covering. There are the BMP TLV, the enterprise bit, and the path marking. Next. We had also a master student from ETH here in Zurich, Livio, with us. He was working on the visualization of the BMP data. So what you see here is basically from the router's perspective, taking the BGP next hop for given prefixes into account, and then basically draw the network map. And for that purpose, the BGP local RIP metrics, the route monitoring metrics were being used. And he's currently working on new visualizations, where he's also including information from the route policy tracing and also the path marking, so we can actually see to which BGP RIP the routes are actually being installed, which are being used for ECMP primary, and also which route policy was actually in charge of, or was showing basically which route policy introduced which BGP attribute changes onto the network. So next slide. Here, short explanation what data pipeline he was using. So we had PMA-CCT on the data collection, Apache Kafka and Apache Druid for message broker and time series DB, and Plywood based on Node.js, basically, which is querying the database, and D3.js for visualizing the graphs. Next. So what we learned is, I think what was special in this hackathon is we had 3 newcomers that they brought some quite interesting questions and new ideas into it. One here, just as an example, was since basically the BGP peer establishment, peer up, peer down, is could depend on a BFT session. Basically, an interesting idea could be to enhance the peer up, peer down that far that we can actually tie it down to an actual BFD session. So we know that basically when a peer goes down, which BFD session was responsible for it, or if BFD causing the peer to be down. The young push CPU memory collection was actually very detailed, and that helped us to really correlate it to the BMP timestamps. The bad thing is it was all virtual, so no beers, no cocktails afterwards, but let's hope for the next IETF hackathon that it will be back physically. Any questions? If not, thank you very much. Looking forward for your feedback on the mailing list, or if you have any interest or question, it would be great to have more people on the next hackathon.
So I have a question. This is Jeff Haas. What implementation was being monitored? I think I missed that at the beginning of the presentation.
On the network render side?
Yeah, what devices are generating the BMP that you're dissecting?
We had an MPLS Inter-AS option C network here, and it was Huawei VRP.
It was Huawei, thank you.
Welcome.
Any other questions? Thank you so much for your presentation. It is much appreciated that you and the team set out to have a hackathon despite IETF not being its usual IETF. So I very much appreciate you guys putting in this effort.
You're welcome. Thanks a lot.
Cheers. All right, next up, we have a presentation from Michael McBridge. If everything is working out as we thought it would work out. I don't think I see Michael in the participants list. Is anybody else from Draft McBride Grow ASPath Prepend on the call right now? There already was some discussion on the mailing list about a best current practices document around the concept of ASPath prepending, what the upsides are and specifically what the downsides are in various deployment scenarios. I think we'll have a presentation the next IETF meeting, but in the meantime, I would encourage people to take a look at the Grow mailing list and chime in on the 00 draft about ASPath pre-bending. I think we have then arrived at the end of our agenda. Oh, Paulo wants to say something. Paulo, the floor is yours.
Hey, Job. Hey, Chairs. Can you hear me?
I can hear you. Thank you.
Fantastic. So, dear Chairs, I wanted to ask you one thing. Like, we have this lockrib draft, which is pretty much, finished, or there has not been any comments, any updates, if not a version bump for 1 year now. It's if I see the IETF status, it's in last call. I mean, shall we give it the last kick and move forward or not? And the reason I ask this is because, the two reasons I mentioned, like there has been essentially no work for almost 1 year. But as you see from the hackathon, we are already, building the software, a couple of layers above that, right? So I don't know, we have something that is working there is no update, what shall we do?
That's good feedback. And I do think the fact that you are already producing new work, which depends on the lockrep draft, is a very good reason to solidify the lockrep draft in the IETF's publication process. So the chairs will take it up as an action item to analyze the current stage. Sorry, there's an incredible echo, so it's a little bit hard to talk. We will take up as an action item to analyze the current status and get back to you in the next few days on what the next step is.
Fantastic. Thank you very much.
Is there any other business? Going once, going twice. I would like to thank everybody for attending this relatively short Grow session, and see you on the mailing list. Thank you all.